Hello my colleagues, my name is Magid Kamil, civil engineer, and we'll start another topic. Our subject today is to determine the inverse of a matrix by using elementary row operations and use it for solving simultaneous equation by the lower upper factorization. We will later discuss this method, which is called also the Doolittle's method. First, let us discuss how to get the inverse of a matrix by using elementary operation. We are using the augmented matrix on the left-hand side. Will be written as A denoted, the matrix A denoted by capital A, separated by a line, and this is the identity matrix I. The identity matrix is as shown. In the row echelon form, we write the augmented matrix as A matrix, separated by a line with vector B. We do elementary operations and convert matrix A to the new upper matrix, and we use back substitution to get the value of X column vector. For the inverse of a matrix, we will write the augmented matrix, but in the left side, instead of writing matrix A, we will put the identity matrix I. Through row operations, the left side of the augmented matrix will become I. Then the right side of the augmented matrix will be the inverse of the matrix A. We will move to the next slide. There are three operations. The first one is to swap of rows, changing from row 1 to row 2. For example, changing the location, and multiplies or divides each element in the row by constant. The third operation is replacing a row by adding or subtracting multiple other rows. We can say, for instance, R1 plus 2 R2, or R1 minus R3, where R1 is the first row and the R3 is the third row itself. For example, if we have a matrix that is 2 by 2, it is required to find the inverse of this 2 by 2 matrix, where A is -3, -2, 7, 4, respectively. In our solution, we will use the augmented matrix. We write on the left-hand side our matrix A, we divide by a line, and we are putting this identity matrix. In our case, it will be 2 by 2. The diagonal, as we can see, 1 and 1. And the other element are zeros. We want to convert the left-hand side into 1, 1, 0, 0. How this can be done? First, to make the -3 converted to 1, we are multiplying R1 by 1 over 3, and the change we are placing it to put it in the place of R1. So -3 multiplied by -1/3 will be equal to 1, while for the element A12 will be -2 by -1 over 3. It will give us +2 over 3. And the right hand side of the vertical bar will be -1/3 0. While for the second row will be left unchanged. Because that there is no operation required, we have already 0 and 1 in the second row in the right hand side of the augmented matrix. We have 7, 4, 0, 1. The next step will be making this 7 equal to 0, and this can be done by multiplying the first row by -7 and add the value to the second row. So -7 multiplied by 1, and we add 7, will become 0. While for the first row, second column, 2/3 by -7 plus 4 would be equal to -2/3. First row, third column, -7 multiplied by -1 over 3 would be 7 over 3, and the multiplication of 0 will be equal to 0. R2 will become here. Now we want to make -2/3 equal to 1. The next step is to multiply the second row by -3 over 2 and place it in R2. 7 over 3 multiplied by -3 over 2 will be minus 7 over 2. Finally, this will be equal to 1. Our next target is to make the 2/3 equal to 0. This can be done by multiplying the second row, which is 1, by minus 2 over 3, and we add the value to the first row R1. We get 1, 0, 2 plus 1. And since the second row is unchanged, so it will be maintained as 0, 1, minus 7 over 2, and minus 3 over 2. Finally, this is the inverse of matrix A, which we are looking for. It lies in the right-hand side portion of the line. The inverse matrix value can be also obtained through the adjoint of matrix A. There is a rule for the matrix A. If it is 2 by 2, we are replacing and we make a swap. The minus 3 will go down while we are going to change the sign of 7. It will become minus 7 and the minus 3 will become plus 2. But again, we are going to divide by the determinant value, which is equal to minus 3 by 4 minus, open 1 bracket, 7 by minus 2, which at the end will give us a value of plus 2. The inverse of the matrix is obtained by dividing the adjoint of A by the determinant. The adjoint is 4 plus 2 and minus 7 minus 3 divided by the determinant value, which is plus 2. If we compare between the results which we have obtained earlier, we will find that they are matching to each other. Thanks a lot and see you next time, and goodbye.